For this question, an object is launched vertically in the air at 49 meters per second from 7-meter tall platform. Using the projectile motion model, h of t equals negative 4.9 t squared plus v naught t plus h naught, where h of t is the height of the projectile, t seconds after its departure, v naught is its initial velocity in meters per second, and h0 is the initial height in meters. Determine how long it will take the object to reach its maximum height. What is the maximum height? So in this example, we're given this function that they're calling the projectile motion model. So h of t equals negative 4.9 t squared plus v naught t plus h naught. So v naught stands for initial velocity, and we are given initial velocity right here. The object is launched vertically in the air at 49 meters per second. That's a velocity or a speed. So we're going to be able to complete this projectile motion model using the given information. It also has h naught. H naught stands for initial height. And we are given the initial height of this object. It is a 7-meter tall platform. So that object is being launched from a height of 7 meters. So filling in that information, we now have a complete projectile motion model for the situation that we're presented. So that's negative 4.9 t squared plus 49 t plus 7. Just a little bit of background information. Although it's not described in this problem, this part here is actually related to being the Earth's gravitational pull, and it's got acceleration due to gravity here. So it actually is negative 1/2 acceleration due to gravity. And in meters per second, the acceleration due to gravity is 9.8 meters per second squared. And so that's why we see that negative 4.9 at the front of this formula, because of acceleration due to gravity on Earth. Okay, so continuing on, the question is asking how long, so the question is asking for the time that it takes for this object to reach its maximum height, and what is that maximum height. So in this example, the model that is given to us, we can see is a quadratic function. We know some information about quadratic functions. The graph of quadratic functions are either parabolas that face up or parabolas that face down. And in this example, we have a leading coefficient that is negative 4.9. Whenever that leading coefficient is negative, we know that we have a parabola that faces down. Once again, this question is asking for maximum height, and that maximum height is going to occur at the vertex. So in order for us to find how long it will take to reach the maximum height and the maximum height itself, we need to find that vertex. So quadratic functions come in the form f of x equals ax squared plus bx plus c. And with that, we have a vertex formula. And we can get the vertex is HK. We can get the x-coordinate of the vertex by following this formula, negative b over 2a. And the y-coordinate, we'll get that by substituting negative b over 2a into the function. That will give us the y value. So for our example, a is the coefficient of t squared, that's negative 4.9. B is the coefficient of the t term, 49, and c is 7. So our x-coordinate of the vertex will be negative 49 over 2 times 4.9. Let me get my calculator out. And 2 times 4.9 is 9.8, and I've made a mistake here and I just want to correct it. I plugged in 4.9 as A, but it's a negative 4.9. So this should be negative, and negative divided by negative is a positive. So that's coming later. 2 times negative 4.9 is negative 9.8. And then we want to do negative 49 divided by negative 9.8, and that gives us 5. So we get the x-coordinate of the vertex to be 5. Then we're going to find the y-coordinate of the vertex. We're going to substitute 5 into our function. H of 5 is negative 4.9 times 5 squared plus 49 times 5 plus 7. So we'll work this out in the calculator. 5 squared is 25. 49 times 5 is 245. This is a plus. Negative 4.9 times 25. Negative 122.5. And 245 minus 122.5 is 122.5, plus 7 is 129.5. So we've got the vertex of this quadratic being 5, 129.5. Let's make sure we know what these values stand for. Most of the time, well, usually ordered pairs are x's and y's. In this example, the variable used in the equation is a t, so this is really a t, and our y part is an h, so we've got h there. So this value of 5 is representing time, and this value of 129.5 is representing height. So this object reaches a max height of 129.5, and I think it's meters that we're using in this problem. Yes, meters. Meters at a time of 5 seconds. So this is going to help us answer the 2 questions. Determine how long it will take for the object to reach its maximum height. It will take 5 seconds to reach the maximum height. What is the maximum height? The maximum height is 129.5 meters. In this question, the price P and the quantity X sold of a small flat-screen television set obeys the demand equation below. That's referring to this equation here. How much should be charged for the television set if there are 60 television sets in stock? What quantity X will maximize the revenue? What is the maximum revenue? What price should be charged in order to maximize the revenue? We have the equation. This is the demand equation. P equals negative 0.17x plus 323. So we're going to be able to answer part A using that demand equation. P stands for price. That's how much should be charged. X stands for number of television sets. So we're given the number of television sets. We're going to be able to calculate how much should be charged. So if there are 60 television sets in stock, we're going to set a price of negative 0.17 times 60 plus 323. Let me use my calculator. Negative 0.17 times 60 is negative 10.2 plus 323 gives me 312.8. So in part A, we should charge $312.80 if there are 60 television sets in stock. In part B, it's referring to revenue. They have a formula for revenue. The formula for revenue is X times P. Number of items sold times the price you sell it at will give you the revenue, the amount of money that you're bringing in. So before we can answer part B, we need to build the function that represents revenue. So revenue is X times P, and P we're going to use this right here. Negative 0.17x plus 323. That's negative 0.17x squared plus 323x. So now that we have a function that represents revenue, we can start to answer part B. What quantity will maximize the revenue, and what is the maximum revenue? The function that we have here for revenue is a quadratic. And we know the graph of a quadratic is either an up-facing parabola or a down-facing parabola. And because our leading coefficient is negative, we know that it's this down-facing parabola here. Anytime the leading coefficient is negative, we get a down-facing parabola. We're looking for the maximum, and the maximum will be at the vertex. So we're going to be able to answer part B of this question if we find the vertex of this revenue function. We have a formula for the vertex that we're going to use for, I'll write it across the top here, for any quadratic function that is written in the form ax squared plus bx plus c. The vertex, which is an ordered pair hk, can be found using the vertex formula. H is negative b over 2a, and k, the y-coordinate, we're going to get by plugging in that negative b over 2a into the function. So that's how we're going to get the vertex. In our function, we have a equaling negative 0.17 and b equaling 323. So we'll find h, the x-coordinate of our vertex, by doing negative b over 2a. That's negative 323 over 2 times negative 0.17. negative 323 over, let's do that multiplication, 0.17 times 2, and that's negative 0.34. So then we'll do 323 divided by 0.34. That's a negative divided by a negative, which is a positive, so we get 950 as the x-coordinate of the vertex. Then we're going to get the y-coordinate of the vertex by substituting into our revenue function. We're substituting 950 into the revenue function, which gives negative 0.17 times 950 squared plus 323 times 950. So let's do 950 squared. This is a big number. That is 902,500. We need to do 323 times 950. 306,850. And we'll do negative 0.17 times 902,500. That's negative 153,425. And then I will add that 306,850. And so that gives me 153,425. So we've got our vertex being 950 and 153,425. Make sure we know what these numbers stand for. So in our equation we have the variable x, and then the function that this is revenue. So we are going to get a maximum revenue of $153,425 when we have 950 televisions in stock. So that's going to allow us to answer the questions in Part B. What quantity of X, what quantity of television sets will maximize the revenue? So 950 television sets will maximize the revenue. And what is that maximum revenue? That's 153,425. So we have one more part to go. In Part C, what price should be charged in order to maximize the revenue? So price is right here using the demand equation that was given. So in Part C, we'll use that demand equation. P equals negative 0.17x plus 323. So I'm going to use this 950 as x. That was the number of television sets. Negative 0.17 times 950 plus 323. So that's 0.17, negative 0.17 times 950, negative 161.5, and I'll add that to 323, and that is a positive 161.5. So we should set a price for the television sets of $161.50 in order to maximize the revenue. Thank you for checking out my videos. Have a great day.